Hi, it's Mr. V. Sorry I'm not there today. Wanted to give you guys a quick tutorial on how to do this practice worksheet if you didn't pick up on it yesterday. So what we're doing, the goal of this is to take information from a position versus time graph, really any general position versus time information, and graph it on a velocity versus time graph. Okay, so the first part of this packet, not the last part, involves going from position versus time to velocity versus time, and you are not going to do the second part of the packet today. So let's look at what's graphed on this. This is position versus time, and this object is not going up then down again. This object's going forward and then backwards again. So it starts here, and it's going to move to +6, move to the right to +6 in 4 seconds, okay, and then move backwards to 0 in 6 seconds. So let me see, 4, 5, 6, 7, 8, 9, 10, and end up there. So it's going fast to the right and then slow to the left. Okay, now what would that look like on a velocity versus time graph? Well, first thing, do not copy these numbers here. These numbers will never be the same as these numbers here. You don't know what these values are until you calculate what the velocities are from the slopes of this graph. So let's find the slope of this graph. The slope of the graph is the velocity, which, as we know, is displacement over time interval. All right, so what is the displacement here? It would be 6 meters minus -6 meters over 4 seconds minus 0 seconds. So that is 6 meters minus a -6, which is going to be 12 over 4. So if we divide 12 meters by 4 seconds, we get 3 meters per second, +3 meters per second. All right. So what we're going to do is this part here is going to have a speed of 3 meters per second. But before we set up our axes, let's find the other slope here. Now, starting at 4 seconds and ending at 10, it goes backwards from 6 meters back to 0. So let's find that displacement. That would be a displacement of -6 meters in +6 seconds. If I take 0 minus 6, that's -6, and if I take 10 minus 4, I get 6 seconds, which is clearly a slope of -1 meter per second. So that would be the velocity for the second part. All right, so by mathematically calculating these slopes, by taking the rise and dividing by the run, we can find the numerical value of this slope and then plot it below. So let's make up a scale. Looks like we have the largest magnitude is 3. So I'm going to go 0, 1, 2, 3. Easy stuff. So I'm going to put 3 here. I'm going to put -3 down here. Obviously, this would be -1. And for the first 4 seconds, I can actually draw some guidelines down like this. I drew these graphs vertically on top of there. We know that at this instant, these velocities are also going to change. So I plot 3 meters per second for the duration, that time interval of 4 seconds. And at that point, you see it's going to change direction and go to the left. So down here, remember, this is positive. This means right, and this means left. Why am I writing out of order? I don't know. So this means it's going to the left at -1 meter per second, like that, and you're done. So this graph is a plot of the slope of this graph. And if I ask you, hey, how fast is it going at 2 seconds? You can go, okay, well, at 2 seconds, it is going 3 meters per second. All right, the 3 is kind of tangled up with my right, but you can see that's a 3. So you can actually read the velocities right off the graph, and just like you'd read the positions off the graph if you needed to find out how fast it was going at a certain time. All right, I hope that makes sense. Give it your best college try. Write in pencil because you may have to erase a lot. All right, I will see you tomorrow. We are going to have a standards quiz on Monday, not tomorrow. We're going to do a fun activity, kind of a challenging activity with real equipment tomorrow to help review for that, and we'll also go over your last quiz. Have a good day.